Hello everyone. Today we will see some practice questions or foundation questions from the chapter Thermochemistry, and this is part 2. Let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slide, and today we will going to see some practice questions from question number 15 to question number 29. So let's start with question number 15. Consider the reaction 4NO2 plus O2 will give you 2 into O5 molecule, and del H enthalpy change for this reaction is minus 111 kilojoule. So if N2O5 is formed instead of N2O5 gaseous, so if solid form will form instead of gaseous in the above reaction, the reaction enthalpy value will be, and given the enthalpy change of sublimation for the N2O5 molecule is 54 kilojoule per mole. Options are minus 165 kilojoule, 54 kilojoule, 219 kilojoule, and minus 219 kilojoule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see the answer. Answer is option number A, which is minus 165 kilojoule. So let's see how. So this is the reaction which is given in the question already. 4NO2 plus O2 molecule will give you 2 molecules of N2O5 in the gaseous state. And the del H for this reaction is minus 111 kilojoule, which is also given in the question. But we have to find out that if N2O5 in solid state is formed, the del R for the reaction, del H for the reaction will be. So basically, we have this equation, but in between, the solid is forming, a solid form of N2O5 is forming, which is directly converting to the gaseous forms. So what will be the del H for the solid form conversion? And the solid to gaseous form conversion is given, which is heat of sublimation, that is 54 kilojoule. So we apply the Hess laws here. So Hess law says that the overall enthalpy of a reaction is the sum of partial or individual steps enthalpies, right? So the enthalpy of formation plus enthalpy of fusion plus enthalpy of sublimation will give the enthalpy of reaction, which is for this reaction, which is minus 111 kilojoule. So on putting the values, we have to find out the enthalpy of fusion. So we take it from we take it at left hand side, and the other things will be at right hand side. So del H of reaction minus enthalpy of sublimation. On putting the values, we have enthalpy of fusion is minus 165 kilojoule. Thus the enthalpy of formation for N2O5 solid is minus 165 kilojoule. So correction, F is for formation, right? So this is enthalpy of formation, enthalpy of reaction minus enthalpy of sublimation. And on counting, enthalpy of formation for N2O5 solid state is coming out as minus 165 kilojoule, right? So option A is the correct answer. Okay, let's move to the question number 16. The amount of heat absorbed by 70.09 gram of water for their complete vaporization is. We have given the mass of the water here. Options are 23,352 joule, 7,000 joule, 15,813 joule, 1,58,200 joule. So we are talking about big terms here. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number D, which is the highest. So the heat absorbed Q is given by Q equals to mass into latent heat of vaporization. So this is given by the formula, and mass we have 70.09 gram mentioned in the question, and on converting to kilogram it is 0.07 kilogram. So latent heat of vaporization is approximately 2260 kilojoule per kg, or about 40.79 kilojoule per mole for 1 mole of a water. So it is known thing, like it is a constant thing, so we use that thing here. So latent heat of vaporization we use in the terms of kg, so it will be 2260 kilojoule per kg. So Q will be 0.07 mass multiplied by the latent heat of vaporization, and it will be equal to 1,58,200 joule. Okay, so option D is the correct answer. Let's move to question number 17. Delta H formation of O3, CO2, NH3 and HI are 142.2, minus 393.3, minus 46.2 and plus 25.9 kilojoule per mole respectively. The order of their increasing stabilities will be. So options are O3, CO2, NH3, HI, CO2, NH3, HI, O3, O3, HI, NH3, CO2, or NH3, HI, CO2, O3. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So the energy absorbed is inversely related to the stability of the compound, or we can say the energy released is directly related to the stability of the compound. So these are two phenomena we are using here. So we know that the enthalpy change is positive for the endothermic reactions, and which are less stable for the forward reaction, and enthalpy change is negative for exothermic reaction, which is more stable for the forward reaction. Hence, we can see that this enthalpy is in positive, this enthalpy is in positive, and these two are in negative. And negative is more stable towards the forward reaction. So, more negative, more stable. So, first CO2 will come, and then NH3 will come, then HI will come, and then O3 will come. So, energy absorbed is inversely proportional to the stability of compound, and released is directly proportional to the stability of compound. So we have the order here, that is CO2 less than NH3, less than HI, and less than O3. Okay, so this is the order. So let's move to the next question, question number 18. Del H naught of atom B is 134.5 kilocalorie per mole, and del H naught of atom F is 118.86 kilocalorie per mole. So del HF naught of BF3 molecule is minus 271.75 kilocalorie per mole. So we have to find the average BF bond energy. Options are 97.7 kilocalorie per mole, 116.6 kilocalorie per mole, 135.4 kilocalorie per mole, or 254.3 kilocalorie per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. The dissociation of BF3 molecule can be written as BF3 is giving B and 3F, and the del HF for this reaction is given as minus 271.75 kilocalorie per mole. So del HR, for that is enthalpy for the reaction, will be equal to the product minus the reactants, right? So del H naught of B plus 3 multiplied by del H naught of F minus del H naught of BF3. On putting the equations, we have del H naught of B given 134.5 plus 3 times del H naught of F given 118.86 minus del H naught of BF3 which is minus 27.75. In total, it is coming out as 762.83 kilocalorie. And the enthalpy of the reaction can also be written as thrice multiplied by the average BF bond energy, right? That is the energy needed to break how much bonds, right? Which is 3. So BF bond is present, 3 BF bond is present. So 3 into average bond of BF energy, and so on dividing the 762.83 by 3, we have BF bond energy equals to 254.3 kilocalorie per mole. Okay, hence option D is the correct answer. Moving to question number 19. In a calorimeter, the temperature of the calorimeter increases by 6.12 Kelvin. The heat capacity of the system is 1.23 kilojoule per gram per degree Celsius. What is the molar heat of decomposition for the ammonium nitrate? Options are minus 7.53 kilojoule per mole, minus 398.1 kilojoule per mole, minus 16.1 kilojoule per mole, or minus 602 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. So the molecular weight of NH4NO3 is 80 and the heat evolved is C del T. We can use the formula. C is 1.23 given and del T is 6.12, and as it is given that temperature of the calorimeter increases by 6.12, so 6.12 is the factor. So molar heat of decomposition will be mc del T. So 1.23 multiplied by 6.12 into molecular weight, which is 80. And on multiplying, it is coming out as 602 kilojoule per mole. And we have to write it in negative sign. So with negative sign, it is minus 602 kilojoule per mole. Why? Because heat is evolving. So that's why the molar heat decomposition should be in negative. Hence option D is the correct answer. Let's move on to the question number 20. The bond dissociation energies of gaseous H2, Cl2 and HCl are 104, 58 and 103 kilocalorie respectively. The enthalpy of formation of HCl gas would be. Options are minus 44 kilocalorie, 44 kilocalorie, minus 22 kilocalorie and 22 kilocalorie. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. This is the reaction of formation of HCl, half of H2 plus half of Cl2 will giving you HCl. So the del H for this reaction will be can be equal to summation of bond energy of reactants minus summation of bond energy of products. So half of bond energy of H2 plus half of bond energy of Cl2 minus bond energy of HCl. So we have given values here for the bond energies of H2, Cl2 and HCl. On putting that values in this equation, we have this equation, and on solving this equation, we have del H equals to the enthalpy of formation of HCl equals to minus 22 kilocalorie, right? So the correct answer will be option C. Let's move to question number 21. Given that C plus 4H will give you CH4. So del H for formation of CH4 is minus 166 kilojoule. The bond energy of CH will be. Options are minus 415 kilojoule per mole, 41.5 kilojoule per mole, 832 kilojoule per mole, or none of these. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. We know that del H is equals to bond energy of reactant minus bond energy of product. Since reactants are individual atoms in this reaction, they are not molecules, right? They are individual atoms. So the bond energy of the reactants will be 0 because like there are no bonds, so there is no energy needed to break them, right? So following this reaction, we have del H is minus 166 kilojoule equals to 0 minus bond energy of product, uh, that is 4 into bond energy of CH bond. So CH bond is 4. That's why we are taking 4 in the coefficient, in the multiply. And the bond energy of CH will be coming out as 166 divided by 4. Minus minus will cancel out. So it is coming out as 41.5 kilojoule per mole, which is given in the option B. Hence, B is the correct answer. Let's move to question number 22. If at 298 Kelvin, the bond energies of CH bond, CC bond, CCC bond, and HH bonds are 414, 347, 615, and 435 kilojoule per mole respectively, the value of enthalpy change for the reaction CH2 double bond CH2 plus H2 forming the ethane molecule is at 298 Kelvin. So options are plus 250 kilojoule per mole, minus 250 kilojoule per mole, plus 125 kilojoule per mole, minus 125 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. So we have this equation given in the question, right? So we have to find we have given the bond energies of different bonds, right? We have to find the value of enthalpy. So we know this equation of relation between bond energy and enthalpy of reaction. So bond energy of reactants will be these two will be the reactants, right? CH2 double bond CH2 and H2. So CH bond is forming 4 times. So 4 times of bond energy of CH plus bond energy of C double bond C, as one bond is forming C double bond C, plus bond energy of H2 minus 6 times bond energy of CH, as in this molecule we have 6 bond of CH. So 6 times bond energy of CH plus bond energy of carbon-carbon bond, which is only 1 times. So on solving this equation, we have minus 125 kilojoule per mole as enthalpy change for the reaction given in the question. Hence, D option is the correct answer. Okay, let's move to question number 23. Given that enthalpy of formation of N2O is 82 kilojoule per mole, bond energies of N triple bond N, N double bond N, O double bond O, and N double bond O are 946, 418, 498, and 607 kilojoule per mole respectively. So we have to find the resonance energy of N2. Options are minus 88 kilojoule per mole, minus 66 kilojoule per mole, minus 62 kilojoule per mole, or minus 44 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, the correct answer is option A. So we have the formation of N2O reaction here. That is N2 plus half of O2 will give you N2O. Or as the bond energies of different type of bonds between two atoms is given in the question. So we can write this equation in terms of bonds, which is N triple bond N plus half of O double bond O will give you N double bond O. So on using the equation that enthalpy of reaction equals to bond energy of reactants minus bond energy of products, del H equals to bond energy of N triple bond N plus half of bond energy of O double bond O minus bond energy of N double bond N plus bond energy of N double bond O. So we will count the every type of bond present in the reaction between the two atoms. So on putting the values which is given in the question, we have this equation. On solving this, we have del H equals to plus 170. So resonance energy we know is experimental value minus calculated value. So we have calculated the value of del H is 170 and we have one given value of del H which is 82. So 82 minus 170, it becomes minus 88 kilojoule per mole. Hence option A is the correct answer. Let's move to question number 24. Using the data provided, calculate the multiple bond energy of a C triple bond C bond in C2H2. The energy is, take the bond energy of CH bond as 350 kilojoule per mole, and we have given three equations here also. 2C plus H2 will give you C2H2, del H is 225, 2C will give you 2C in gaseous state, del H is 1410 kilojoule per mole, and H2 gaseous will be become 2H gaseous, so del H will be 330 kilojoule per mole. So options are 1165 kilojoule per mole, 837 kilojoule per mole, 865 kilojoule per mole, or 815 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be D option. So for the calculation of C triple bond C bond energy, we must first calculate dissociation energy of C2H2, right? So C2H2 will dissociate in the form of 2C plus 2H. We put this equation as first. And by using the given bond energies in the question and enthalpies, C2H2 will give 2C plus H2, and the del H will be minus 225 kilojoule per mole for this. And we just reverse this equation which is given in the question, and rest two equations are same which is given in the question and their del H, and we represented them as second, third and fourth. So on adding equations second, third and fourth, it will give the equation first. Okay, so the final reaction will become C2H2 will give you 2C plus 2H, which is first reaction, and del H for this reaction will be, like we add second, third and fourth reaction, so del H will also be we also add the del H for the particular reactions, like del H for second, del H for third, del H for fourth equals to del H for first, which is coming out as 1515 kilojoule per mole. So, and then we can use the relationship between del H and bond energy equation. So del H of this reaction will be equal to bond energy of reactants, which is bond energy of CH, which is two bonds are forming of CH, so 2 multiplied by bond energy of CH plus bond energy of C triple bond C, because only one bond of C triple bond C is present, so plus bond energy of C triple bond C, and they are elemental, so their bond energy will be 0 because they don't have any bonds, so no energy will be needed to break them. And now on solving this equation, we have bond energy of C triple bond C as 1515 minus 700, which is 815 kilojoule per mole. Okay, that's why option D is the correct answer. Move on to question number 25. The standard enthalpy of formation of NH3 is minus 46 kilojoule per mole. If the enthalpy of formation of H2 from its atoms is minus 436 kilojoule per mole and that of N2 is minus 712 kilojoule per mole, the average bond enthalpy of NH bond in NH3 is. Options are minus 964 kilojoule per mole, minus 352 kilojoule per mole, plus 1056 kilojoule per mole, or minus 1102 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. We have given this equation and for the formation of NH3, and we have given the del H for the formation of this reaction. So bond enthalpy of NH is given as 46 kilojoule per mole, and positive sign is taken because energy is supplied to break NH bonds, and two atoms for H is giving H2 molecule. Del HF for this process is this minus 436, and so bond energy of H2 will be 436. Two nitrogen atoms will give you N2 molecule. Del HF is given minus 712 kilojoule per mole, and bond energy for N2 bond will be 712 kilojoule per mole. This bond energies we are calculating by putting the enthalpy and the bond energy relation. Okay, because here they are elemental, so their bond energy will become zero. So del H for the reaction, we can find out the half of bond energy of N2 plus 3 by 2 of bond energy of H2 plus minus bond energy of product, that is 3 times NH. 3 times bond energy of NH. Now putting the values in this equation, we have 3 times bond energy of NH is 1056, and on dividing by 3, we have bond energy of NH as 352 kilojoule per mole. Hence option B is the correct answer. Moving to question number 26. The heat of combustion of benzoic acid is minus 2546 kilojoule per mole at 25 degrees Celsius and 1 atmosphere. The del E is. Options are minus 1555.6 kilojoule, minus 2244.7 kilojoule per mole, minus 2544.76 kilojoule per mole, or minus 2868.66 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. We have this equation for the heat for the combustion of benzoic acid, and del Ng you can see is minus 0.5 because the gaseous molecules in the product is 7 and in the reactant is 7.5. So 7 minus 7.5 will be minus 0.5, and we know that del H equals to del E plus del NgRT. And on putting the values in this equation, we have del E equals to minus 2544.76 kilojoule per mole. So option C is the correct answer. Okay, let's move to question number 27. Del H for combustion of ethane and ethine are minus 341.1 and minus 310 kilocalorie respectively. What will be the ratio of calorific values of ethane and ethine respectively? Options are 1 is to 0.95, 0.65 is to 2, 0.95 ratio 1, 0.02 ratio 1. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So calorific value of heat produced by 1 gram of fuel is given by, so for the ethane, it is minus 341.1 divided by 30, which is their molar mass, equals to minus 11.37 kilocalorie per gram. And for the ethine, it is minus 310 upon 26, which is minus 11.92 kilocalorie per gram. So on getting their ratios, For the ethane and ethine, we have 11.37 ratio 11.92. And on solving or simplifying this, we have 0.95 ratio 1. So option C is the correct answer. Let's move to question number 28. We have given assertion and region. Assertion is combustion of all organic compounds is an exothermic reaction, and region is the enthalpies of all elements in their standard state are 0. Options are assertion and region both are correct statements, and reason is the correct explanation of the assertion. B. Assertion and region both are correct statements, but region is not the correct explanation of assertion. Assertion is correct and reason is incorrect. Both assertion and reason are incorrect. Okay. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so we have answer option B. So in a combustion reaction, sum of enthalpies of reactants is greater than the sum of enthalpies of products. Therefore, combustion of all organic compound is an exothermic reaction. And also enthalpies of all the elements in their standard states are 0. So both the assertion and reason are correct, but R is not the correct explanation for the assertion. Hence option B is the correct answer. Let's move to the last and question number 29. Statement first and second. The enthalpy of formation of H2O liquid is greater than that of H2O gaseous. The enthalpy change for condensation reaction from H2O gaseous to H2O liquid is negative. Options: statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Statement 1 is true, statement 2 is true, but statement 2 is not a correct explanation for statement 1. Statement 1 is true and statement 2 is false, and both the statements 1 and 2 are false. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So both statements first and second are correct, and statement second is the correct explanation for the statement first. So, okay. Thank you.